Hello, I am Dr. Bernice Mostert of SA Studbook. I am responsible for the genetic evaluations of the dairy and small stock breeds in South Africa. Thank you for this invitation to talk on a subject that's of real importance to me, breeding a sustainable Jersey for Africa. Cows differ in their ability to cope with environmental disturbances, being it pathogens, heat waves, or even changes in feed composition and feed quantity. Resilience of cows can be defined as the capacity of cows to respond and overcome these disturbances, safeguarding their ability to contribute genes to the next generation and thereby rendering sustainability to the breed for long time survival. Lifetime resilient cows can be defined as those cows completing multiple lactations that exhibit good productive and reproductive performance, that face few health problems that are easily overcome, and that are efficient and consistent in their milk production. We often refer to these cows as silent or the invisible cows of the herd, as they have sufficient production to keep them in the herds and experience no problems that renders the attention of the producer. Resilience of cows, improvement of resilience can have benefits on different levels. It will improve on-farm productivity. It will improve the animal health and the welfare of the cows. It will reduce the impact that the cows have on the environment. It will also reduce the need for the use of antibiotic and medicinal intervention, leading or resulting then into easy to manage and healthy herds, and therefore also have a positive impact on labor and labor costs. In the last century, the focus of selection and breeding of dairy cows was on the improvement of milk yield. And because milk yield have a moderate heritability, we saw tremendous increases in the genetic potential of dairy cows. However, that came at a cost because we saw also deterioration in butterfat and proteins percentages and in the health and fertility of the cow, with a real deterioration observed in udder and feet and leg traits, and the longevity of the cows declined. But over the last 2 to 3 decades, total merit indices all over the world also started to include traits like fertility, disease resistance, conformation traits, efficiency, calving traits, and survival of the cows. We therefore have much more balanced breeding over the last few decades. In countries like Canada and the Netherlands, we said that they also now look at including the resistance of cows to heat stress and diseases in their total merit. There's also research focusing on the adaptation of cows to variation and feed and forages that affects the product and the fertility. Precision stock farming technology to us precise insight behavior, health, activity of cows, much more effective to manage. Cows can be diagnosed and treated much quicker, of course, helping to costs of a dairy enterprise down. This can also be used to signal insemination times very effectively. Application of this technology therefore supports improved health and fertility of our cows, aiding in a sustainability of populations. Impaired resilience impacts reproductive performance of a cow to reap, therefore a valid of the cow's resilience. In the Netherlands, a lifetime resilience score has cows. Based on all the calving events of the cow's age at first intercalving period in comparison to the herd average, as well as the number of the insemination of a cow's last lactation, with pins built in for all the curated treatments that the cow received, and when she's also option for each day culled before the days in milk. Approach can easily employ the South African Jersey population. Calving events, age at first calving and intercalving period information can be obtained from birth notifications of all the Jersey cows that has been registered on Logix, which is SA Studbook's official database. Furthermore, information on fertility, medical and culling events are currently being captured from farm software and pipelined into Logix in a chronological manner. Another approach that can be followed is using the variation of the daily milk yields of the cows. Milk yield of cows shows response to environmental disturbances. And with research, it has been indicated that cows with less variance in their daily milk yields have better udder health, less ketosis, and better longevity. Heritability estimates for this trait of between 20 and 24% are being published in the literature, indicating that selection response can be expected when selecting for this trait. Also, favorable genetic correlations has been observed between cows showing less variation in their daily milk yields and functional traits. But what information are currently available to the South African Jersey breeders? First of all, comprehensive herd management reports are being sent on a weekly basis to our producers. These reports give a herd overview with regards to all births that have been recorded, heifer mortalities that occurred, the pregnancy status of the heifers and the cows of the herd, all lactations that have been completed, as well as cow erosion that occurred over the specific monitoring period. Furthermore, reproduction trends are being given for the heifers as well as for the cows of the herd for various reproduction traits. And this is then against the breed average, the dotted lines on those graphs, as well as with the median of the top of the population, which is the green dotted lines. Then on top, we also indicate the average for this reporting period for that specific trait, and then indicators showing if the herd improved, which will then be the green arrows, or deteriorated, which will then be the red arrows with regards to the previous reporting period. And then at the bottom, the average of the herd over the last 12 months are indicated. This is then also done for all the information obtained from the latest official milk recording test on which the herd participated. Also then supplied to the breeder or to the producer is timeline trends. For example, this graph indicates the milk production of every cow that's currently in lactation in the herd. And then with color coding, we indicate which cows are the fresh cows, which will be the blue circles, And then the cows that have been inseminated is the yellow blocks. Those that still need to be inseminated are the orange dots. And then the red ones are the cows that's been inseminated but tested not pregnant, while our green um, blocks then indicate all the pregnant cows of the herd. We also give information on the average cow weight across the lactation within parity groups, as well as the average weight changes that occurred over the lactation. Then the producers are also supplied with various action lists to which he can respond immediately. For example, all the heifers that's not sorry, I cannot see what is standing there. For all the heifers that's older than 2 years old, indicating her pregnant status there, as well as the action list with regards to all the cows and heifers that's ready for PDs. The cows that has not yet been inseminated, also indicating their days in milk and weight change that occurred within the last 2 weeks. And then the cows that are dry for more than 55 days. The cows with very long intercalving periods. Cows under pressure due to too high somatic cell scores or too low lactose percentages, indicating that cows are under stress. And then all the cows that have possibly acidosis, and an action list for all the cows that possibly might have ketosis. These management reports therefore assist our producers to act timeously and to ensure the sustainability of the herd. We then also supply our breeders with genetic information on their herds with regards to genetic reports sent to them 3 times a year. But we also have a publicly available platform called sadairybuls.com, where the genetic and genomic information of the breeders' animals are being indicated. This is done for all the South African cows as well as bulls, but also for all international AI sires. And those international AI sires breeding values are indicated on the South African scale, meaning that it is directly comparable to the specific herd's genetic levels. So information obtained or showed on this platform is, for example, this is the South African Jersey bulls information. You can see on top there, we indicate, we have the genotyped logo indicating that this bull was genotyped. And then we indicate the genetic levels for all the traits and selection indices that we estimate in the genetic evaluation. Left on the top, we have the genomic information with regards to single gene traits. And then at the bottom left are the pedigree information for this animal. And the breeder can request up to 10 generations information to see on this specific animal. South Africa has an established genomic reference population for the Jersey breed, and this allowed us to develop and implement a single-step GBLUB genomic evaluation, which have been running since 2020. This means that we can supply our breeders with genomically enhanced breeding values and indices, which mean that they can do more accurate selection on especially their young animals. Having genomic information also enable us to supply our breeders with genomic information on the genetic constitution of the animals with regards to specific single gene traits, for example, the constitution for beta and kappa casein. We can identify the carriers of DGAT1 and ABCG2, and we can also indicate the genetic constitution with regards to the horned or polled stateness of the cows. Then also for several unwanted and lethal genetic disorders, we can identify the carriers for mulefoot, Reuther syndrome, and the Jersey haplotype 1 um, infertility mutation. We can also do, of course, genome-wide association studies because we have a representative database to identify genes that have associations with specific traits, specifically with regards to our Jersey population. Our latest development for our Jersey breed is the Genetic Efficiency Index. This is an indicator of the adaptability and the resilience of our South African Jersey population. We use this to give an accurate ranking of the cows with regards to their production of dense milk versus their body size. And the data we need for this is official milk recording information because we need milk, butter, fat, and protein yields, as well as linear scores. We use the linear scores to construct a body weight composite index. Now, linear classification is done by the Breed Society, and that information is also captured onto Logix. Currently, we also obtained cow weights from farm software, and as soon as we have enough weights available across herds and across generations, we will also include cow weight into our genomic evaluation, and we will then replace the body weight composite with the actual cow weight breeding values in the efficiency index. When we implemented this index, we saw that there are really ample variation available within the herds and across herds to be able to make genetic improvement with regards to this trait. For example, we have 3 cows here, and you can see that they are within the same herd. Their efficiency indices vary from 81 up to 128. You can see cow A have the lowest genetic levels for milk, butter, fat, and protein yields, giving her the lowest dense yield index of 104, but she's quite a large cow with a body weight composite of 120, and this then gives her an efficiency index of 81. Compared to her is cow C, with the best genetic levels for milk, butter, fat, and protein. Her dense yield index is 120, but she is the smallest cow with a body weight composite of only 104, making her then the most efficient of the 3 cows. Then, of course, of immense importance to us to ensure the sustainability of our Jersey population is the management of the level and the rate of inbreeding in our Jersey herds. For this, we developed a mating module that's also available on SA Studbook. On this platform, the breeder can indicate what the level of inbreeding is that he will allow in his herd. And then he can select bulls according to his herd's specific breeding objective. And this mating module will then allocate these bulls to the cows of the herd in such a way that the most genetic improvement will be obtained, but with the least increase in inbreeding. So you can see here at the bottom are one of the herds that are using this mating module. This herd really ran into very high levels with regards to inbreeding, with a rate much higher than that of the breed. And then in 2010, he started to use this module, and you can see he managed to decrease his inbreeding by more than 2% since 2010, and then since then he managed to keep the rate of inbreeding of his herd below that of the breed. The South African Jersey population moved over the years from total mixed-rations to more pasture-based environments. The breeding objective of our population have already been adapted to focus on more capacity to process forages efficiently and also then concentrating especially on sound feet and leg traits. The medium frame width capacity of the Jersey breed makes them better adapted to the South Africa's warm climate compared to our larger framed dairy breeds. The sustainability of our South African Jersey breed are therefore assisted by faster genetic gain through the use of genomically enhanced breeding values and selection indices, by including efficiency in breeding objectives, by allowing of farmers to do precision breeding for milk quality traits based on genomic information, by eradicating unwanted and lethal genes from our population, and by managing the rate and level of inbreeding in our herds. To conclude, surviving in a changing environment is a reality today. Informed decision making based on data and scientific evidence are really essential. Breeders need to contribute phenotypes and genotypes of their animals to the South African database. This will allow for applied research and support to sustain the future of the Jersey breed in Africa. Thank you very much.